Hey everybody. This presentation is going to be a little bit different. I really don't have any slides, any PowerPoint slides to aid me in the presentation, so I'm just going to use the iPad by itself and do a little bit of the drawing by myself, so bear with me with my drawing skills. All right, we have to jump a little bit in the book to section 4.3. Like I say, the units are going to be comprised of multiple chapters, and this unit is comprised of chapter 3 and chapter 4 together. 4.3 talks about the composition of solutions, and you'll notice how I write solutions, S-O-L-N. I'll abbreviate it like that for the duration of the class. Now that we know a little bit about the mole, we can actually ask ourselves, if we create a solution, which is something dissolved in something, how many particles are in the solution, and in effect, how concentrated is the solution? So let's get some terms out of the way. All right, let's look at a beaker. And let's say that we've got some type of liquid in the beaker. Let's just call it water. And let's say that we have some type of particle in that solution. And we'll place a whole bunch of orange dots in there. And we're just going to call that sugar right now. And we all know that sugar does dissolve in water. Now in this case, we have two terms. We have a solvent, and we have a solute. Okay, the solvent is the material in the liquid state. The solvent is doing the dissolving. So we're going to call it the material doing the dissolving. Actually, I'm not going to write that, guys. Just my penmanship on this is horrible. So the solvent is the material doing the dissolving, and the solute is the material being dissolved. In this case, our orange dots, and I'm referring again to those orange dots as just a whole bunch of sugar molecules, because again, we know that sugar dissolves in water. Now when we add these two things together, solvent plus solute, what do we get? Well, we get a solution. Okay, we get a solution. Now, the question could be asked, all right, well, how concentrated is that solution? So how do we know what the concentration is? And that's where knowing the idea behind the mole is gonna help us out. All right. So let's go back to our beaker. And again, it's going to have the same amount of liquid in it and the same orange sugar molecules dissolved in it. So the concentration of our solution is going to have a special term. We're going to call it molarity. Molarity is going to be defined as the moles of solute that are dissolved in liters of solution. Moles of solute dissolved in liters of solution. We can express this mathematically. We can say molarity equals moles of solute over liters of solution. And for brevity's sake, we're going to abbreviate that with molarity will be a capital M. Okay, that's the symbol for molarity, capital M. Molarity equals MOL per liter. So this is a nice new conversion unit that we are going to have right here, this moles per liter. Just like grams per mole is the conversion unit we use for molar mass, moles per liter is the conversion unit we'll use for molarity. All right, so molarity equals moles per liter. Now in the case of our beaker here to the left, let's say that the water level here is up to 50 mils. We know that that entire volume is not due to just the water because there's sugar molecules dissolved inside of the water. So the question would ask, well, is that the volume we use here for the denominator of our molarity? It sure is. It sure is. So remember, it's solution, and solution is the addition of the solute and the solvent. Let's also say for a second that we know, because we figured this out, we put about 346 grams of sugar into the beaker. And that actually, if you do the math, adds up to about 1 mole. So let's say that there's 1 mole of sugar. And I would ask you, what is the concentration of this solution? Well, if we go back to our equation, how many moles of solute do we have? We have 1 mole divided by liters of solution. Now be careful here. Okay, it's 50 milliliters, right? That's 0.05. Okay, 0.05. So our math is going to be 1 divided by 0.05. Go ahead and do that on your calculator if you get a chance. And if you do that, I'm so calculator dependent. If you do that, you're going to come up with, a 20 molar solution. Okay, so 20 with a capital L. All right, that's pretty concentrated. So that's molarity. Pretty simple.